So in the tube cutter, we have here an SPI interface. You'll see in the programming code, we have an M code programmed, which will happen real time, P30, W26, and D1600. And I have this floating palette, which is for a trump laser, which is currently in remote mode. You'll see we can name the fields conventional. It accepted the programming to peak demand 30, 1.6 kilohertz, and a width of 26 microseconds, which can be changed. Much like the built-in SPI interface. We have tabs for system performance, which include system on time and laser on time. Also communications. We can watch the transmit and receive messages coming through here. This is merely for troubleshooting, but we could select a different COM port, and there's a list of commands which can be tested here. But we like to leave it in parameter editor, and if we click the remote, we can take over the laser and rotate through on, standby, and off, and the laser will warm up and we have that communication. So the floating palette can be integrated back. Serial buffer is full. We can float the dialog and take a careful look at what messages are communicating. We see the messages and a lot of activity. That's on the communication tab. The laser will go from bright green to dark green when it's ready for use. Now with the given program uploaded, we have an embedded M133 code which communicates with the laser, which is set at P30, W26, and D1600. When we run the program, that data will be handed over to the laser. You'll see the laser's activated, now turned red, and we see some power coming across, something near 1 watt. And in the camera we saw flashes, which is indicative of the laser shooting on the part. Also in the tube cutter we have a field for a camera, which we can change the alignment, change nozzles, change settings. We have a part counter over here, which is now set to cycle program. It's enabled. We have dedicated program buttons, laser spot, U offset that can be changed by the end user. Actual position, we could rotate through velocity and following error. We could even change inches to millimeters, counts. Here we have a very specialized optical focus, so we can move the glass up and down inside the head, so we could just go up and down, clicking, and then drag the bar up. Right now it's at a location 119. That's through a Copley amplifier. We have our jog palette, dedicated navigation, and also program override, and of course a start and stop button and some dedicated I/O on the right. We can turn on the oxygen and nitrogen, which we choose because we have 2 I/Os and 2 gas. Here on the left we have inputs which show us when e-stop has been pressed or when there's not enough air.